Hello everyone, my name is Nikola and I work as a QA software engineer on Top 11.
And I'm Luka, I'm also QA software engineer on Golf Rival. And today we'll talk about rebuilding testing automation, a startup-inspired approach. Why startup-inspired? Well, certainly not because Nordeus is a startup company, but because we wanted to have startup-like solutions. So we wanted to gain maximal value with minimal effort. Today we'll firstly introduce our two games, Top 11 and Golf Rival. We'll talk firstly about them for a bit. Then we'll see which challenges we faced while working on these two games, what we did first in order to solve those challenges. Of course, then we'll go to automation and all the effort we had about automation, and then we'll see which learnings we had from this effort.
So first I want to tell you a few words about Top 11 game, which I'm working on. It's a top grossing football management game in the world, and it was launched in 2010. It's available on iOS, Android and web platform, and so far we have more than 300 million registered users. And the fun thing is that Jose Mourinho and Xabi Alonso are our brand ambassadors.
And Golf Rival is the second top grossing mobile golf game worldwide. We have more than 60 million registered users so far. Just this year we celebrated our 7th birthday. What is interesting for Golf Rival in comparison to Top 11, it's not built in-house, but we got to run this game 3 years ago. Since it wasn't built in Nordeus from scratch, we needed to encounter some different tools, some different systems, technologies and so on. But for all these different kinds of problems, for both of our games on Top 11 and Golf Rival, we somehow ended having same or pretty similar solutions.
Our two games are 7 and 15 years old, which means a long period of time of keeping up with the constant changes of market, devices, operative systems, trends and everything. It wasn't always easy, but what's the one thing that will always get us closer to keep up the game fresh is to do constant regression testing. It's not always an easy job, and we tried to make it efficient and also effective. The other challenge we face is knowledge silos, because if you have a game in some long period of time, it means that many people have worked on it and they changed teams, changed games, and it means that it wasn't easy to maintain this knowledge in some centralized place. So we needed to tackle this challenge in many ways, how to maintain all this in our heads. And also the other challenge we always face is working with live ops and maintaining live ops, because some of our live ops were built in some different periods of time. It means that they were built in some different manners. Collect all of them on one place and work with them isn't always easy job to do.
And now let's see how we tackled all these challenges. First thing is something I like to call our immune system. And like in a human body, where we have a lot of bacteria and viruses, you don't go and try to kill each bacteria and each virus in order for you to be healthy, but you try to boost your immune system. And that's something we also try to do in our games. We didn't go and try to fix every issue, each bug, to know each line of code, but we wanted to boost our defense lines in order not for bugs to go into the production. So what we needed to improve, we needed to improve our CI/CD pipelines, we needed to work on our test practices and testing tools, and we needed to strengthen up our observability. to know what's happening in our game actually. For our CI/CD pipelines, we first introduced validators for our configurations, and that was basically the easiest thing to be done. So we had a lot of configurations for various parts in our game, which were changed by different roles, game designers, PMs, developers. All these people weren't in sync many times and didn't know what was supported, what's not. So the easiest thing was for us to okay, we'll build some config validator, and it won't go to production if something isn't supported or not. Second thing, we needed to increase our unit test coverage. We basically didn't have for top 11, that was many years ago. For Golf Rival, that was a few years ago, but we didn't have a lot of unit tests in our code, so many bugs that were basically logic bugs were going into the production, and this was basically something that should be a definition of done when we finish some event, when we finish some feature, we need to cover it with unit test, and that's new practice we improved. And the last thing was that we wanted to focus on building test tools and testing optimization. We didn't have a lot of test commands. We didn't have some tools for to easily maintain all these live ops events, all the things we push into the production, and all this was incorporated with our Team City job, which became our new CI/CD pipeline, from which we now can easily release, easily deploy, and fix things much faster. And second thing was our testing practices. This is something we are really proud of, that we have our environments which mimic production. And in these test environments, we like to basically test all our features. That's our playground, where we break things, shift time, our test commands are enabled there. And on these test environments, we basically do everything and reassure us that this thing will also work for real users in production. Second thing we wanted to do with our testing practices is that we wanted to introduce testing in production. Although our test environments were very powerful and are powerful, we figured out that so on, we sometimes miss something, and some bugs actually slip into production. And we figured out, well, that's because the behavior of users. When we are testing, the behavior of users isn't the same on test environments and on real production accounts. And that was one thing, and the second thing was basically the performance issues, where on these test environments we have some mimic data, and on production we have millions of users. So we want to introduce testing in production for us, so we get all those edge case bugs first before our players. And the last thing we wanted to do is to boost our LiveOps pipeline deployment. And the main goal was for our LiveOps to be easily maintained and easily to set up. Before, many of our events even took days to be released, because there we had a lot of configurations and art assets, game design configurations, some developer configurations, and we needed to make one system that will basically allow each member of team to easily deploy any event in just a few minutes. And now we lower that time for some events for them to be released in day, to be released in just maybe a few minutes.
So the last thing in this immune system is observability. So Luka said, we can't get rid of every liability in our game. Like in our body, we can't rid of every bacteria and viruses. So the thing we can is to know what's going on in our body, so to know what's going on in our game, what problems we have, so what bugs in production, in design, in logic we have in production, so that we can accordingly prioritize solving these issues and to incorporate this together with some new things we develop and to prioritize also with that. Also, what we did, we added alerting on top of our technical metrics, which are most important business-wise. We are alerted when something goes wrong and that we can react accordingly in no time. What we did also is that we introduced stability monitoring as a definition of done. So you can't say that you did something or you developed something if you didn't cover it with metrics, observability, alerts, etc. All this is ground floor before any fancy automation and regression testing. We can now talk a bit about our approaches when it comes to automation itself. I'm gonna tell you something about our approach and attempts of automation testing in the past, and after that we'll talk a bit about our current system we use and what are our plans in the future. We wanted to cover the whole game with some screenshot tests. They are basically tests that will compare some images. We have a reference image, which is a good image of the game in the screenshot. So we will take screenshots automatically and compare these two images to know if something changed and if everything works fine. This was a good idea, but realization seemed to be a bit different. So we tried to cover everything, the whole game with it. It means that it was enormously expensive to maintain because our game is constantly changing, and every time something changes, like in art or live ops, etc., these images, screenshots, are also changing, and we have a lot of falsely failed tests because of all these changes that happen. So someone needed to update these reference images constantly, so it was very expensive to maintain. And we didn't get enough value from it because it wasn't RIO positive, because we spent more time to maintain tests than we spared time not testing by manually. From that, we learned some valuable lesson that we do not need to cover everything. We need to cover some things that really matter, that are core features of our game, that we need to be sure that they are always in good shape. To focus on some flows that are deterministic and that are not changed every now and then. We realized that we just need minimal test coverage baseline, and to follow it and to cover more than 80% of our needs with less than 20% of effort. So what we did, we explored some third-party libraries when it comes to automation testing, and we on Top 11 and Luka on Golf Rival, we chose different approaches, but it turned out that we got the same outcome.
And now I'll talk about similarities in both our approaches on Top 11 and Golf Rival. While working on our new automation approach, both systems used game objects to interact with our UI. Both automation needed to be incorporated with our CI pipeline, and each unity test needed to be run before build. And the differences in Top 11 and Golf Rival are that on Golf Rival we were using Unity engine testing tools and automated QA libraries. And on top 11 we actually had custom code. Why we did that? Well, because on top 11, since the system is 15 years old, it was much easier to make something custom and not to like integrate it with all the other systems. And on Golf Rival it was easier for us to use some Unity libraries that were actually supporting automated testing in Unity. Other difference is that on top 11 we used game object paths, and on Golf Rival we used game object IDs in order to navigate and to iterate with components in game. Of course, on game object IDs is a better approach since if we change something in our UI and architecture, our test would still work because they could navigate through those objects through their IDs. And if we navigate like on top 11 through the game object paths, then each time something changes in our architecture and in the UI, we also will need to update our Unity tests. But that's fine since Nikola said that we'll actually cover only deterministic paths and paths that aren't changing so frequently. We still wouldn't need to spend a lot of time maintaining already written automated tests. And which results we got after finalizing our automation efforts is that basically we got much faster feedback loop. It was very important for us to immediately see if something failed, and we had pretty like redundant and actually boring practices for testing our F2E, that's our tutorial, some first time user experience, and entering the game, starting first match. In each regression we needed to cover same paths over and over and over again. When we cover them with our automated tests, then it saved us a lot of time, and we knew immediately if our core game actually worked or not. Tests are now owned by whole team. Both QAs and developers are responsible for these tests, for maintaining them and to writing and coding new ones. And at the end, we have a better quality in both our games and a happier team. We have more time to do much funnier stuff. And we'll now show you actually how one of our tests on Golf Rival work. This automated test actually just tries to enter on our test environments and to see if login works. It will accept privacy policy and we'll enter the game, and there our test will end successfully.
So what's next? It's scaling forward. As I said, we needed to set minimal coverage baseline, so we didn't reach it yet. We are yet to cover everything that we imagined and to integrate this approach tightly into our release pipeline. So it becomes no-brainer that before each release we have everything we need tested by our system. As we said, we learned that this approach is not good with working with some fragile UI elements which are not deterministic, which are frequently changed. But what's good for us is that the most important part of our games are not undeterministic. They are something from meta, and all these things can be easily tested by this approach. So, and once again, the biggest learning was not to cover everything, just to cover the essential things. So we cover the more than 80% of value with these tests.
So question of the day, can we fully automate testing? Well, short answer would be no. And longer answer is partially. And as you said, we can cover only deterministic stable paths. But not only because that, it's because mobile gaming isn't the same as the rest of IT industry. So a lot of stuff also depends on just user behavior, how users would interact with game, how they feel the game, what they do, what they don't. Like there is so many paths we can't cover, and actually if we try to cover, we would probably fail because we don't know what some user would try to do. And we don't want to also limit our users to explore new things and to maybe do something we didn't anticipate, which is still very funny and we like for our users to explore. So we actually never want to fully automate everything, since then we will basically say this is only the correct way to play this game and everything else is wrong, which is, you agree, not fun. So what are key takeaways? For the end, first is I'll say automation requires a real understanding of our game. To start thinking about automation at all, you'll agree you need to know your game thoroughly. All the systems, how users interact with game, not only for developer perspective, but also from user perspective as well. Working with legacy means adapting the system, not replacing it. If you're replacing it, then we're basically making a whole new game, and that doesn't make sense. We agree that you need to start small, like automate high value, low complexity paths, iterate on that, and when you see you gain the value from that, then expand more and cover the rest of the game. Focus on testability, not just on tests. It's great to cover your game with as many automated tests, as many unit tests, but also make your game testable. Work on your test environments, on the testing tools, on test commands, and so on and so on. And for the end, you need to collaborate closely with the whole team. So not only with devs, but also with PMs, game designers, artists, and so on. And it's very important to say that this would never be possible if this effort only was done by QAs. We had great support from our developers, and I think that QA shouldn't come at the end of the process, but needs to be integrated from the very beginning and to cover the whole process thoroughly with all the other roles as well.
So that would be it. If you have some questions, or if you have your stories to share, your approaches you used, leave them in the comments and we'll be happy to discuss them.